Hello, everyone, and welcome back to the second day of the Arab MTech and Startups Conference. It's my pleasure to introduce Mr. Mohamed Abuali to present digital transformation and industrial AI. Mr. Mohamed, over to you, please.
Yeah, Linda, thank you for the introduction. Hey, good morning, good afternoon. My name is Mohamed Abuali. I'm based out of Cincinnati, Ohio, and I'm a managing partner at IoT company. So my presentation today will actually focus on using artificial intelligence on the manufacturing floor, okay, in manufacturing. As a company, we are actually a global organization. IoT Co. stands for Internet of Things Company. We come from manufacturing. I personally worked at Toyota in the past, and a lot of our data scientists and consultants, we come from aerospace and automotive backgrounds. We have three practices as a company. We have our own product that does predictive analytics of machines on the factory floor using AI, but we also provide a turnkey solution around training and around Internet of Things technologies. So I'm gonna focus my presentation today on an education, actually. I wanna give an education on three things. First, there's a lot of terminology being used, and I wanna set the stage for, what is IoT, which is Internet of Things, what is IIoT, which is Industrial Internet of Things, and what is Industry 4.0, which is the fourth industrial revolution. I want to focus on one specific technology, which is AI and predictive analytics. And I want to give a summary of how companies today are winning and how you can win ROI, which is return on investment, by using artificial intelligence in your daily operations. If you have any questions at any time, just please drop them in the Q&A and we will try to get to the questions. So I'm going to give a high-level picture. Internet of Things is not a new field. Internet of Things has been around for many years, actually, for decades. And it was primarily used for safety critical industries. So I'm talking monitoring of airplanes, monitoring of power generation, jet engines, and safety critical, human critical assets. But today, some of the lessons learned are being used in industry, in manufacturing, which is referred to as the industrial Internet of Things. So when you look in a factory today, there is what's called an automation pyramid. There are machines, there are data acquisition systems, there are execution systems, and there are business systems. So the issue today is a lot of these layers are fragmented, or they are not connected to each other, or they are missing. So there's a lot of gaps in manufacturing. So Industry 4.0 was actually a Germany-born initiative. And this initiative has the vision of helping factories and manufacturing to realize how we can close the loop on these different layers here. So actually, Industry 4.0 has four key pillars. And I like to start from the right and go backwards, actually. The first pillar is, what is the return on investment? What is the justification? What is the business case? So the business case drives adoption, and the business case is very important for success. Then you have connectivity. So am I connected, right? Am I collecting real-time data from my operations? And how do I do that if I'm not? Then we talk about analytics. How can we use the connected data to drive improvements on the manufacturing floor? And this is where I will talk about predictive analytics today, very briefly. And then technology and infrastructure and scalability of the technology across the operations. So keeping this in mind, I want to give a simple definition of Industry 4.0. And I also want to make sure everybody understands that there were multiple iterations of industrial revolutions that have already occurred. But unfortunately, a lot of companies are still operating on an Industry 3.0 level, okay? They are using computers, they are using IT systems, but in many cases, they are not connected to each other, okay? There's a lot of disconnect in the operation. So the fourth industrial revolution, very simply speaking, is combining traditional manufacturing practices with technological world. And I'm talking the use of AI, artificial intelligence, blockchain type of solutions, connected solutions, predictive analytics, right? To drive productivity. So fourth industrial revolution is about the digital connected world. It is using the internet, it is using analytics, it is using advanced technology like AI and blockchain to drive improvements in the manufacturing sector. So there are obviously barriers, right? And some of the barriers include, I have old IT systems in my operation. So I have an old business system, I have an old MES system. What can I do to connect those systems, right? And sometimes it's very difficult to replace those systems. I have old machines on the factory floor. There's a survey that says 50% of machines on the factory floor today are actually old. Old meaning they don't have Ethernet capability. You cannot connect them to the network. You cannot extract data from the machines. So, maybe they are dumb equipment, but they are very capable equipment. They are making good parts. So how can I communicate with these very old machines on my factory floor? Workforce, right? I have aging workforce that is retiring, and I have what's called digital natives, right? Folks like you who understand how to use technology, and they're entering manufacturing and they're trying to use those solutions, right? So people graduating and retiring and people coming into the factory floor. How can I train them to use the technology? And then new processes, right? Human machine interfaces. Now I have to do things in a new way. I need an HMI. I need operators to be using technology to run their day-to-day operations. So how can I make sure I have intuitive, right, user experience that could easily be used by operators and people? And I put this at the bottom, funding, because I believe that if you have a strong business case, if you have a strong justification, then funding will not be an issue because you will have an ROI from the conversation that you're trying to put in place. So, a very short summary, there are 3 circles, and those 3 circles must intersect if you want to be successful with Industry 4.0. It is not just about technology. It's more importantly about process and about people. Technology, process, and people are the key to profitability and ROI by using any Industry 4.0 technology, whether it's AI, whether it's blockchain, whether it's whatever your organization is trying to adopt today. So please don't always think technology, but think what is the successful recipe of having technology and process and people, and you will be very successful. This is the case for manufacturing. Our vision has always been, how do you drive your manufacturing factory towards a zero downtime and a zero waste or zero defect operation? I want to maximize my uptime and I want to reduce my scrap. And that's a perfect manufacturing plant. But to get to this level, it's a journey, right? I need to understand what is my success criteria. I need to define my business case, and I need to deploy the technology that helps me drive towards the business case. So OEE, which is overall equipment effectiveness, that's a key metric in manufacturing to measure productivity. We're talking reducing downtime. We're talking optimizing your spare parts. We're talking preventive maintenance scheduling in a better way. We're talking reducing waste. I can summarize this whole slide by saying we want to move away from a reactive, time-based approach to the operation to a predictive and prescriptive approach to the operation. And to do that, we need technologies like AI, artificial intelligence, and predictive analytics. And that's one technology that I want to focus on today for the next few minutes. And again, if you have any questions, just please write it in the Q&A and we will try to get to them. I want to start with a very high-level slide, okay? McKinsey had this case study about a year ago or publication, and they defined 4 key disruptive technologies for Industry 4.0. I'm only going to talk about one, which is analytics and intelligence. But there is a key message here that sensors and hardware are getting cheaper, RAM and storage are getting cheaper, the use of cloud is increasing, computational power is increasing, which means that I'm able to capture more data, I'm able to analyze more data, and I'm able to make decisions faster, okay? And in addition, there is new advanced processes that are happening, like additive manufacturing and 3D printing. And there is new ways for human-machine interaction, right? At the end of the day, there has to be a human that uses this data to make decisions, right? So how can I take all this blockchain, AI, and everything and give it to someone who is not a PhD, someone who is not a data scientist, someone who doesn't know blockchain, and make sure they can use it and drive improvements, right? It is not as easily said as done, right? Technology, process, and people is the message here. So if we look at predictive analytics and the idea of zero downtime, zero defects, we're talking about a worry-free manufacturing process, okay? I should have no worry running my operation because I know I will not go down, no machines will go down, and I know that I will not make bad parts, okay? But to achieve that, it's a three-legged stool. There are 3 steps here. There is data. I need data. There is adoption of artificial intelligence on the factory floor. And there are use cases, right? What am I trying to achieve? Am I predicting machine issues? Am I predicting quality issues, right? So we talk about predictive maintenance for the zero downtime operations, and we talk about predictive quality for zero defect operations. It is not just about predicting machine downtime, but also what is the impact of an issue on the machine to the actual part that is being produced on the machine, right? So it's a 2-step process. There is correlation between the machine parameters and the quality parameters, directly proportional to each other. So the key issue is actually right here in the middle. How do I do that? And if you look at a manufacturing plant, there is a wide variety of applications, right? There is robotics, there is machining, there is molding and casting, there is stamping machines, and there is surrounding equipment, like on your assembly line. You might find pumps, motors, gearboxes. So it's important when it comes to predictive analytics to create a set of solution templates, okay? Solution templates are very important to be successful. Solution templates allow you to understand what data do I need to capture and how to analyze this data using AI very quickly, so you can deploy and run these solutions in the factory floor in about 8 to 12 weeks. So within 2 to 3 months, we are able to actually collect the data, train the AI models, and deploy the AI models and train the team so they can use the data very quickly to drive improvement in maintenance and quality. So under each one of those gray boxes is actually a 6-step process, very systematic process. The first step is, what data do I need? And we have that well defined. We know the type of data for robots and stamping and casting and so on. And then how do you process that data, process the signals, extract the features, assess the health? So if I'm the user, if I'm the maintenance person, I only see 3 things. I see the health of my machine. I see a prediction with an accuracy of when the machine will fail. So I know when the machine will fail before it fails. And I see a diagnosis. What is the root cause of the failure of the machine, right? So if we take some quick examples, the first example is actually on robots, okay? So this is an industrial robot application. There are certain data points we capture from the machine. For example, the torque, which is the current of each axis of the machine, the speed and the position of each axis of the machine. And we understand the failure modes, the key failure modes that are used to predict problems on this robot. So now if I'm the end user, if I'm a maintenance guy or a maintenance person, I can immediately see 3 things. I can see machine health. This is how healthy my machine is over time. My machine has started to degrade. It has drifted away from the normal. And then I'm able to see a prediction with an accuracy, of course, of when this machine is going to fail. So now I know when to schedule maintenance on this machine, when to order a spare part on this machine, and how to diagnose issues on this machine, okay? And now I'm moving away from a reactive mode to a predictive mode of running my operation. But another important message here is the user experience, right? I don't need to be a PhD or a data scientist to use a screen that looks like this, right? I can be a maintenance person. I don't need to be a data scientist or a statistician, and I can quickly see the data that I trust, and I can quickly act. So my message here is always design your solutions with very strong user experience, right? Your user is not your technical experience type of person. That user needs intuitive things and intuitive ways. Here's another quick example. This is a machine tool. It's a CNC machine. I have a tool, I have a spindle, I have a feed axis, I have a coolant, a lot of moving parts. But the more important thing is there is a defined data map. We know what data parameters to capture from that machine. And we know how to apply artificial intelligence, machine learning on the data and convert the data again to an intuitive user experience for assessment of health, prediction, and diagnosis, right? This is actually a bearing failure on a CNC machine, and you can catch the bearing failure like 2 to 4 weeks in advance. So just imagine almost a month in advance, you're able to predict failure on this machine. These are actually two use cases. So in the United States, there's an association called NAM, National Association of Manufacturing, NAM. And the NAM has an Artificial Intelligence Leadership Award. And this award was actually given to those two clients last year. One is last year, one is this year. And one is focusing on predictive maintenance. And the other one is focusing on predictive quality, okay? Why I'm showing you this slide is whatever solution you are working on, please always consider 4 things. Consider what is the technical value, what is the velocity and speed that you deploy those solutions, because speed means it is affordable and it is pre-built. And customers today are looking for affordable, accurate, and pre-built solutions, especially in manufacturing. And scalability, how scalable is the solution? Do I need to hire a data scientist to be able to scale my solution? I have 10 manufacturing plants. I have 20 manufacturing plants around the world. How can I scale the solution in a quick and affordable way? And finally, what is the business case? What is the ROI? Usually, a pilot should have an ROI of about 3 to 6 months, and a plant level ROI should always be under 1 year, okay? And then it's easy to justify and easy to find funding and easy to deploy those solutions. So my last message here, and again, this is a lot of content, I understand, for a 20-minute presentation, but I hope it gave you some high-level information that you can take back to your daily lives. And we actually have a full, course and training around this material that takes days. But I want to give you a simple message at the end. And the message is, in order to win, right, we need to think big and start small and prove value and scale quickly, okay? And this is the approach we follow today. And you can, apply this approach in your industry. We talk about an assessment, we talk about technical workshops, and we talk about a proof of value. A proof of value is technology plus business case. Technology plus business equals proof of value. This is not a proof of concept. The solutions we are working on today are not concepts. They have been used in industry for many, many years. And it's very important that we are adding value in our daily lives to the manufacturers and the companies we work with, and not providing concepts, okay? So have a proof of value mindset, a POV mindset, and you'll be able to scale those solutions very quickly. So my message here to the team and the audience is, think big, start small, but act now, because it is becoming a very competitive market globally. And everybody is transitioning from an industry 3.0 mode to an industry 4.0 mode. And think of a proof of value that makes sense to your business, which means it's technology with a business plan objective to it. And today I focus on smart factory, but we also do work in smart products. If you make a product and you have sensors on the product, you can actually use the same analytics and you can offer new business models for your end user. And my last message is always, it is not just about technology. It's about technology, process, and people. And your success is going to be as far as the weakest link. So if you start somewhere where people or process is an issue, you need to address that issue, because this will be a challenge for your deployment. Please connect with me. Please email me. Please add me on LinkedIn. Please follow us. And I appreciate the opportunity to give this short presentation today. Linda, if we have any questions, I'm happy to answer them. Thank you.
If there is any question for Mr. Mohamed Abuali, can you please write it in Q&A or raise your hand and I will put you on stage.
I think they can also write it in Q&A, Linda, is that right?
They can write, yes, in Q&A. We still have 10 minutes. I think, yes. Ali, okay, Ali, go ahead, please.
Thank you, Mohamed, for your presentation. It was very quick, but it has very valuable information. I like the statement that talking about think big, start small, and I'm not sure what the rest was, but it's really a good, solid, wisdom that you have to start with. The only thing is the AI and IoT. It's something new in the most of the world, and I mean, it's like a solution coming before the problems. We have not seen any solid, solutions that can be applied, or it's applied in somewhere, and you can bring it here and use it for all the fields, whether it's in industry or in business or in government. So it will be a good idea if you give us some examples that where can we start with. I mean, if we take an example in a government or in a business, it's like you build a small team that can starting to find how can apply the IoT, or they have to bring some applied solutions somewhere else and trying to adopt it in their organization. I will be happy just if you elaborate or about this topic.
Yeah, it's a good question, Ali, and I think in the Middle East, the oil and gas industry is actually a heavy adopter of AI. I lived in Saudi in my young years for about 15 years, and I saw how Aramco was probably the #1 user of AI, even though they did not call it AI. But I would say there are some sectors that are very mature, and the oil and gas industry is actually very data rich. They have a lot of data, and they're doing things with the data for many years. There are sectors, however, that are not so, like you said, a little bit behind. That could include maybe telecom, and it could include other manufacturing sectors, maybe governments, and so on. And it's usually due to the regulatories and the red tape that it takes to go over this. But my advice is always start with the business case, understand what drives success and which areas of the operation need to evolve, right? Less is more, I would say. Less is more. So 80-20 rule, what is 20% of the issues may lead to 80% of solving the problem. So that's always my advice. Without knowing your business in detail, we always look for the metrics. We understand what drives success, and we find ways to create a small proof of value that makes sense. But at the same time, it has to be scalable, it has to be repeatable, it has to be affordable, and that allows you to create what we call a center of excellence or a center of competence. And this COE or COC can start to take this knowledge and celebrate the success from a pilot or a proof of value and then scale it across the organization. So it is a journey, and it's important to understand that every company, every organization has a different level of what we call digital maturity. Some are maturity level 1, some are high maturity level 5, but we have to benchmark where we are in the maturity scale, and then we have to make recommendations for the future improvements.
Thank you. Thank you, Mohamed.
Thank
Anytime. You. Any other questions, Linda?
No, we don't have any other questions.
Well, thank you for the opportunity, guys, and have a great conference, and stay in touch. Thank you, Linda.
Thank you. Thank you very much. Have a great day.
You too.